And then we're going to go ahead and take a few minutes and allow everyone to introduce themselves and the organization that they are representing today. So I will actually go through just to make sure that we stay in order. So we'll start off with Rachel.
Hi, everyone. So if you attended the first session, you would have met me as well as the research team. I'm a water resource specialist at the West Virginia Water Research Institute. And for those who weren't at the first session, we are a research team that started off looking at THM formation and its association with bromide in the raw water. And through an extension of this project, we started working with various different water facilities, and we realized that we were in a role to facilitate some conversations among operators, regulatory folks, and researchers. And so that's really the goal of this series. If you missed the first session, I'll put in the chat right now the link to our website that has that recording for you to look at after this.
Perfect. Thank you, Rachel. Lance, you're up next.
Okay, my name is Lance Lin. I'm a professor in the Civil and Environmental Engineering Department here at the West Virginia University. I'm the PI for this USGS project, and this the virtual meeting series is the outcome of that project. And I'm pretty much in the supporting role for Rachel, Melissa, and Stephanie. So I'm happy to see, we have this kind of opportunity to exchange experiences and share what we learn.
Perfect. Thank you, Lance. Up next, we have Emily, our presenter for today.
Hi there, I'm Emily Garner. I'm an assistant professor in civil engineering here at WVU.
Thank you, Emily. And we have Melissa.
Good morning. Thank you guys for joining us today. I'm Melissa O'Neill, and I'm the Associate Director here at the West Virginia Water Research Institute. And I also manage a program called Three Rivers Quest, which is sort of how we got started in the THM research side of things. So thank you guys for taking the time to join us today. And we really hope that we can provide some good feedback and that you guys can have some good discussions along the way. So thank you.
Thanks, Melissa. Charles Adams.
We're with Preston County PSD #1. My name's Aaron Watkins. I have Paige Hatch, Robert Williams, and Christian Chittister.
Perfect. Thank you. Jason?
Morning, everyone. I'm Jason Philhart, and I am the project manager here at the Water Research Institute. And I work with Melissa and Rachel on this. I'm working with Rachel and Melissa on this project and on similar projects.
Perfect. Thanks, Jason. Trevor Water and Bobby Riggs. No mic? I think you might be muted. There we go.
I'm Trevor Waters with Granttown Water. I'm Bobby with Granttown Water. I'm off to the side.
Welcome. Thank you for joining us today. And we have Mike Harnick.
I'm Mike Haronic, a district engineer at the State Health Department. I'm at Clarksburg Water Board, and I've talked to some of the operators. They're in meetings right now, but they're going to flow in and out, and hopefully at the end of the day, you'll get their opinions on a few matters.
Amazing. Thank you, Mike. Ben Faulkner.
Ben Faulkner, Princeton, West Virginia, private consultant.
Welcome, Ben.
Thank you.
Jeff Skousen.
Skousen. Yeah, I'm
a thank you.
Professor of Soil and Water Sciences at WVU.
Thank you so much, Jeff. Sorry about that. Mike Anderson.
Mike Anderson, I'm a chief operator, Morgantown Utility Board. I also have Wade Suttle, chief lab technician, and John Smirka, the operator.
Thank you. Welcome. Brian Carr.
Yeah, I'm Brian Carr, Program Manager of the Source Water Assessment and Protection Program for West Virginia DHHR.
Thank you, Brian, and welcome. Looks like I just got to skip Nick Scher.
Nick Scher, I'm a senior mining geologist, mine pool and Karst groundwater transport person for the West Virginia DEP.
Thank you, Nick, and welcome. Stephanie Karchevsky.
Hi, everyone. Sorry, my video's off. I'm having internet problems, but I'm an undergraduate at WVU. I've been working on this project since around February. That's basically it.
Thanks, Stephanie. Stephen Bowers.
I'm Stephen Bowers, working for the town of Paw Paw.
Welcome, Stephen. Mitch McAdoo.
Hi, everyone. Mitch McAdoo. I'm a hydrologist with the United States Geological Survey. I sit in Charleston, West Virginia.
Welcome, Mitch. Thank you. We have Nina.
Good morning, everyone. I'm with Quality Water Services. I am their compliance specialist.
Thank you, Nina, and welcome. And last but certainly not least on my list, Martin Christ.
Martin Christ.
Chris, thank you.
I work for the West Virginia Department of Environmental Protection in the Watershed Improvement Branch. We show up when citizens say, what can we do to help the water?
Perfect. Thank you, Martin. Sorry about that. Well, and my name, Kristen Bauer, and I am the Outreach and Education Coordinator here at West Virginia Water Research Institute and also the Northern Brownfields Assistance Center. So thank you all for giving those great introductions. And with that being said, we'll go ahead and move along to our presentation for the day. You have already met her. Our presenter is Emily Garner, Assistant Professor of Civil and Environmental Engineering, and she will be discussing the management of disinfection byproducts within the distribution system. So Emily, the floor is yours.
Thanks so much. Let me just see if I can share the right screen. Are you all seeing my full screen presentation? Okay.
Yes, we are.
Okay. Thanks so much. Like Kristen said, I'm going to be talking about management of disinfection byproducts in the distribution system. So just, start with a quick recap about why we're here. We know that anytime we've got organic matter in our source water that's going to be reacting with a disinfectant during water treatment, we're going to get the formation of a variety of different disinfection byproducts. So last time, a lot of the focus was on the source water and what's happening at the treatment plant. Today, I'm going to be focusing more on what's going on throughout the distribution system and how we might control formation of disinfection byproducts out in the far reaches of those systems. So, it's really quite a balancing act when it comes to managing disinfection byproducts, between managing risk between pathogens. So we have to have that disinfectant residual throughout our distribution system to make sure that if we end up with any intrusion that leads to bacteria coming into our system or any growth of bacteria, those are things we want some disinfectant residual present to be able to address. But we also, of course, want to limit the formation of disinfection byproducts. And so there's a real balancing act between dose optimization at the treatment plant, as well as managing a wide variety of other water chemistry parameters. But this balancing act continues throughout the distribution system and is impacted by a wide variety of different factors that I'm going to talk a little bit about today. And so I'm going to kind of give an overview of some of the issues on this topic, and then go into a little bit of a case study that my students have been working on here at WVU. All right, so at the treatment plant, and when we're thinking about the source water, we know there's a wide variety of different factors that can impact formation of disinfection byproducts. This can include the type of disinfectant, as well as the disinfectant dose. Of course, those are going to be really influential over what DVPs we might have forming. But the physical and chemical characteristics of the source water are important as well. So things like temperature, Lance really emphasized last time that they found temperature to be very important for formation of DVPs. But pH, dissolved oxygen, particulates, turbidity, all of these can be influential to whether or not we see these form and what types form. It's also important to look at a variety of different organic and inorganic materials in our water, Some of these might be precursors to DVP formation. And so relevant compounds here include bromide, iodide, sulfur-based compounds, and iron and manganese. And finally, biological characteristics of the water are important as well. These can be a source of organic matter that can contribute to DVP formation. All right, so now let's transition to talking about the distribution system a little bit. So this reaction, it doesn't stop at the treatment plant. This holds true, but as we get out into the pipe network, so just depicting a little cross-section of a pipe here, we're gonna have, anytime there's organic matter present, along with our disinfectant residual, we can have formation of these DVPs. And so I just want to give a quick overview of what are some of the different factors out in the distribution system that might contribute to this. And so these are really going to fall into two different categories that I'm going to highlight. One is a source of organic matter. And so those I will highlight with these green boxes throughout this diagram, or issues that exert a chlorine demand or a chloramine demand. Things that contribute to degradation of our disinfectant residual. And I'll highlight those in orange on this diagram. So this might include bacteria. We're going to have formation of biofilms on the inside of pipe surfaces. Those bacteria might include nitrifiers. They might include a wide variety of other bacteria as well, both potentially pathogens that could be harmful to humans, but a wide variety of other bacteria that are harmless, aside from the fact that they contribute to this problem by providing organic matter that can react with our disinfectant residual, as well as exerting a chlorine demand, so lead to the exacerbation of decay of this disinfectant residual. These biofilms aren't just made up of bacteria, though. These bacteria excrete a substance called extracellular polymeric substances, or EPS. This is all that gooey stuff that helps the cells kind of stick to each other and stick to the pipe surfaces. And this is organic, and so it can contribute to DVP formation as well. It certainly will also exert a chlorine demand. We might have intrusion throughout the system. Bacteria or other organic compounds might be able to get in if we've got a break in a pipe or a low pressure event. And so this can contribute to organic matter as well as chlorine demand. We might have sediment throughout the system. I've highlighted this as a chlorine demand. If our sediment is reacting with the residual, that can help to expedite its decay. But there is some element of organic matter that is relevant here. These surfaces can also be, really friendly for microbes to grow on. We might get some bacteria attaching to those, exerting some of these EPS, these extracellular polymeric substances. And so sediment can carry organic matter throughout the system as well. What pipe materials we have throughout the distribution system is going to contribute to that chlorine demand. Some are going to be more reactive than others. And this is particularly important when we're thinking about corrosion of pipe surfaces. Any corrosion reactions are going to consume chlorine. And so all of these chlorine demand issues are really problematic because they expedite decay of that residual and mean that we're going to have to dose more chlorine or more chloramine into the system to maintain the residuals we want throughout the distribution, aimed at controlling things like these bacteria. So just a lot of complex processes here that all kind of impact each other. And so a lot to manage throughout many, many miles of a distribution system. And so this is some EPA data that they published in 2013, but I just wanted to include it here to demonstrate this point that we tend to see the most problems of this nature out in the far reaches of the distribution system where water age is highest. This is, of course, also where we see free chlorine, our chlorine residuals starting to diminish. And so those are the conditions where we see the most formation of disinfection byproducts. This is particularly true of total trihalomethanes. So the far reaches of the distribution system can be often the most problematic for formation of these compounds. But that's not necessarily always the case. So for example, haloacetic acids is what we're looking at here, some more EPA data. We can actually have in the far reaches of the distribution system more growth of bacteria that contribute to biodegradation of these haloacetic acids. And so these actually tend to be most problematic at moderate water ages where we've got a moderate chlorine residual. So there's also a lot of dynamics that contribute to which of these disinfection byproducts are problematic where in the distribution system. So let's talk briefly about strategies for controlling DBPs in the distribution system. So one important strategy, as evidenced by these last couple plots, is that limiting water age can really help to control formation of DBPs, especially those TTHMs. And so we can do that by eliminating dead ends in the system and oversized pipes to make sure we're getting good turnover throughout the entire distribution system. It can also be helpful to control hydraulic conditions in storage tanks. I heard this mentioned in the last session as something that has been helpful. And so this is important because it helps to make sure that there's less water stagnation, less short circuiting where water might sit in portions of the tank and achieve a higher water age as a result of that. So mixing tanks and reservoirs can be helpful for this as well. It is, of course, also helpful to install booster stations throughout a distribution system if there are areas that are really problematic for maintaining that chlorine residual. This is important because it helps to limit the growth of biomass in the distribution system, so we get less of that organic matter accumulating. This also helps to limit, nitrification and other microbial reactions that consume chlorine. It is also important to limit corrosion of distribution system materials. We saw how those will react to consume chlorine. And so making sure that, corrosion control is optimized and, the elements throughout the system are routinely maintained is important as well. It can also be helpful to minimize the presence of sediments by conducting routine flushing and reservoir cleaning. Those, as they start to build up, can contribute to residual decay. And then finally, preventing any sort of contamination in the distribution system from intrusion of stormwater, groundwater, cross connections, backflows. Any sort of intrusion events can be problematic for DBPs. And so making sure that those are well controlled is an important element of this as well. And so certainly it's important to, look at what our different options are for primary and secondary residuals. So here we're mostly talking about secondary residuals. And so there are certainly trade-offs between free chlorine and chloramines. So we're going to see better persistence of chloramines throughout a distribution system, but they have some disadvantages as well. So we see that those chloramines typically result in less formation of our regulated disinfection byproducts, but they're also not as effective at controlling taste and odor compounds. They also have higher requirements in terms of complexity of the technology needed. We've got some extra dosing that we have to do to achieve that chloramine residual. And so just wanted to make a quick note here about trade-offs between these different disinfectants. Okay, so finally, in the last couple slides I've got to share with you, I'm going to be talking briefly about a case study that a couple of my students at WVU have been working on. So let me just start by giving a quick shout out to Erica and Maddie, who have been working really hard on this project. So all credit goes to them. But what they've been doing is collecting samples from a distribution system here in West Virginia from a rural water utility. And so our main goal with this project is actually focused on microbial water quality. So we're not looking so much at disinfection byproducts, but we really want to understand how do the hydrodynamic conditions throughout that system lead to growth of microorganisms throughout the system. Which microorganisms are those? What types of microbes? Are we seeing nitrifiers? Are we seeing potentially human pathogens? Or are we just seeing relatively harmless bacteria that might be problematic because they contribute to issues like DBP formation? So that's the focus of this project. But certainly because there are such, close trade-offs between control of microorganisms in the distribution system and formation of DBPs, we've also collected some DBP data for this study to be able to understand if those microbes are an important factor for DBP formation. So this project is still ongoing, particularly a lot of our microbial analyses. So I'm just going to show you some preliminary data today. So just a kind of a snapshot at what we're working on. So some of the things that we're looking at in this study are, of course, physicochemical water quality, monitoring how that changes throughout the distribution system. We're also looking in depth at microbial water quality. So today, the only microbial data I'm going to be showing you is heterotrophic plate count. So this is a culture method that detects a wide variety of organisms. Many of those are not harmful to humans in any way, but they may be contributing to loading of organics in the distribution system. And so this is just a really rough count of kind of the overall microbial loading throughout the system. But it's not perfect. We don't have any culture media that can grow all microbes throughout the system. And so we're also using some advanced molecular methods that actually look at the DNA of these organisms. So my students are also doing some quantitative polymerase chain reaction. This is a method that targets the 16S RNA gene. So that's just a gene that all bacteria have. And so by counting how many of those genes there are in our samples, we can get a pretty good estimate of how many total cells there were in a sample. My students are also working on some next generation sequencing. And so this is going to be valuable because it will allow us to look at what are the specific bacteria present in each of these samples. So that is all still ongoing, but hopefully some exciting data coming there in the future. And then finally, like I mentioned, because of these close trade-offs between growth of microbes and formation of DBPs, we also collected some DBP data for some of these samples. And because we're really focused on the far reaches of the distribution system as being a place where we know that microbes like to grow, we focused on total trihalomethane since those are the primary problem out in the reaches of the distribution system where water age is highest. All right, so let me start with just some of the TTHM data that we found. This was from some samples collected in June. And so you can see that we did detect TTHMs throughout the distribution system. And this was primarily driven by chloroform in yellow and bromodichloromethane, this light green color along the bottom. And so these sites don't perfectly align with how far they are from the treatment plant, but how they're numbered is a pretty good indication. And so these sites kind of 10 through 14 are where we're starting to get pretty far out into the reaches of this distribution system. And so you can see that when this total chlorine residual starts to drop off, that's where we see the most formation of these DBPs. But overall, good news, at all sites, TTHMs were below the regulatory requirement. So we are seeing relatively low levels of these throughout the system, even at some of these sites where they tend to be a little higher. I just also wanted to quickly look at a couple of trends. So not too surprisingly, our data aligns with what was observed in that EPA data I shared, where at low chlorine concentrations, so those are what's occurring out in the far reaches of the distribution system, that's where we see the greatest formation of total trihalomethanes. So not a surprising trend here, but one I think worth noting. We also saw that temperature was an important driver. So this primarily was important across dates. When we compared samples collected across different dates, we saw that, not surprisingly, those that were collected at higher temperatures had higher concentrations of TTHMs, and that aligns with what Lance shared at the previous session. But interestingly for our study, we found that there was no correlation between heterotrophic plate count, so this rough measure of microbial loading throughout the system, and formation of total trihalomethanes. So we've got, a couple more methods we want to look at before we kind of reach any conclusions here. But so far, we're not seeing evidence that growth of these microorganisms is a key contributor to formation of TTHMs. It's really a lot of water chemistry and physical properties like temperature that are more important for driving that from what we've seen so far. All right, so I will wrap up here quickly. I just want to thank the research office at WVU that supported this work, as well as the Department of Civil Engineering. And I just finally want to thank Erica and Maddie for their work on this project. And if anyone has any questions, I'm happy to take those as well.
Thank you, Emily. It doesn't look like we have anything in the chat, but as I have said before, we definitely welcome you to come off of mute and ask any questions that you may have. We will also have time to add to the discussion more later on, but if you have any questions in regards to DBPs within distribution systems or have any experience that you would like to share with the other attendees, we welcome you to come off mute now.
Emily, I have a quick question. The total chlorine measurement concentration, how much of it is free chlorine versus combined chlorine?
It's all free chlorine.
It's all free chlorine. Yeah.
So do we have anyone that is attending that has any experience with the strategies outlined for controlling DBPs within the distribution system? Emily notated a couple, like limiting water age, controlling hydraulic conditions. Do we have anyone that has any experience with maybe switching treatment methods in hopes of minimizing DBPs? And were there any unattended changes or consequences in other areas that you noticed and would like to share?
This is Aaron Watkins with PSD number 1. We changed processes out in distribution by adding mixers in our tanks, and at first with the dead water that was staying in the tanks, it caused some issues there. But after doing that and doing twice a year routine flush, we've been able to keep our numbers down for the most part.
Great, thank you for that. Has anyone had similar experiences or have anything else to add?
Yeah, this is Mike in Clarksburg. Right now, well, we've got some groundwater systems where THMs or byproducts for that matter aren't an issue, but right now Harmon is having an issue where they were going to put a 60 or a resort development up past about 5 residential folks. So we're worried about keeping the chlorine residual out there. So we're doing a whole study on using free chlorine as a surrogate for water age to see how many days until you hit, I guess, less than a 0.2 or a negligible disinfectant residual. So that's interesting.
Thank you, Mike. I appreciate that.
Yeah, thanks, Mike. That actually brings a question to my mind. If everyone could kind of go around and share what type of research would really be the most beneficial to your system, or what is the area that you're struggling with the most in terms of DBPs, or if you have no issues with the DBPs, please share that as well. So if we could just start off, Aaron, if you could, what kind of research would really help you guys out?
We're currently working with 2 different branches of WVU. I'm more in depth looking into the DPDs, but really since we put them mixers in and we're keeping up with the routine flush and we replace some different blow offs so we can flush the system more efficiently, that seems to be the greatest that has helped us out of everything. I mean, if anything, I would want to go back to the source water and start there and see about knocking them down further before it even gets into the plant, like TOCs and stuff like that.
Great, thank you, Aaron. Would anyone like to add to that or add to any research study or support that they might benefit from in their facility? Trevor, Bobby?
Hey, it's Bobby. We're really interested in trying to find a proper tank mixing system that will help. we're just a water purchaser from the city of Fairmont. And the TTHM's HA5s are sometimes high coming out of there, and we don't have any way to lower them other than through the tanks. And, you know, we've looked at several tank mixing systems, and I need to find one that's going to work for our area without, you know, I don't want to buy something that's not going to work. Because I'm concerned in the wintertime, if we go with some type of variation unit, that thing's going to freeze, because the tanks are always up on a hill. And in the wintertime, you get the sub-freezing temperatures. If that system's going to continue to work, if it's going to freeze up and bust. I mean, I just have several questions, and I've got our engineers trying to find an answer. But if somebody's got something that is working, you got PS number 3, isn't that in Preston County?
Yeah, I'm with PSD 1 out of Arthurdale, Reedsville area. If you want, I'll put my email in the chat. If you want to send me an email, I can give you the design specs and everything, because ours is a floating recirculating system that floats with our tank, and you can adjust and raise the level on it. And I mean, we've gone through a couple winters now and not had any issues. They've been really great to have. And they're actually pretty inexpensive. Oh yeah, dramatically. We used to be in violation left and right. And with implementing that and some system flushing changes, we've, to be honest, knock on wood, we haven't had any issues since.
Okay. Yeah, I can get that information from you.
Great, thank you, Aaron. It seems like we might be able to make a contact to help you out a little bit, Trevor. Does anybody else have any questions regarding maybe tank mixing systems or the concerns that Trevor noted around the freezing of aeration systems? All right. Well, with that, we will continue down the line and see if we have any additional needs for future research, study, or support that will be able to assist facilities within the region. Ben, do you have anything to add? No? Okay. Looks like we have Mike coming on again.
Yeah, I've got a topic that Monumental PSD was doing in that regards to how do you effectively measure if flushing is doing any good, or the impacts of flushing. So 30 some HA5 violations in 2018 for just the purchasers in our county. What Monumental did on their 3 systems is, okay, let's take some special purpose samples before the parent system, which is Fairmont flushes, and then we'll do some compliance samples. And they did that for almost 2 to 3 years and found that the water was better before Fairmont flush than after it reached them and got to their compliance samples. 20-30% higher after the parent system flushed. And it kind of opened my eyes that that wasn't the intent. It really depends on the detention time or the travel time to go out. But how do we effectively measure if flushing is doing what we intended to do?
Thank you, Mike. Do we have anyone else that would like to add to the discussion? I see a lot of cameras went off when I started calling on people. All right. I see Martin coming off of mute.
I'm curious, Dr. Garner had a organic molecule there that I believe would be a fulvic acid. Is there a good feeling that fulvic acids are the largest culprit, or is it is the embedding compound for the bacteria along in the biofilm, is that just as bad? Is there any progress to be made on that?
Now, I had a little bit of a difficult time hearing the entire question. It might have just been me, but do you mind repeating that one more time, Martin? I apologize.
Just a sec, gotta hook up here.
No problem.
Is this better?
That's much better. Thank you.
Okay, so I think Dr. Garner's intro had a picture of chlorine and a fulvic acid. And I'm wondering if the research has shown that fulvic acids are the biggest culprit, or is the whatever comes out of the biofilm matrix, is that just as bad? And are there strategies for controlling one versus the other?
Perfect. Thank you, Martin. Definitely heard it that time. Emily, would you like to address that?
Yeah, that's a great question. Unfortunately, I'm not sure though. That was just a generic pick in terms of an example of organic matter, but I think that's a great question. Yeah, I don't know, Lance, do you happen to know of research in that area? It's not something I'm familiar with.
No, I don't. I don't know if the specific organic compound, how big the difference of that make in terms of TTH information. But it would be interesting to know though, Emily, if the free organic compound contribute more to the TTHM or the organic coming off the biofilm contribute more. I mean, that I don't know if your research will generate that kind of information.
From this project, no, but it's something that I definitely hope to look at more in the future. It's just really getting a better understanding of the role of those biofilms for how influence they have.
Yeah, that'd be great to get an idea how big of that biofilm related organic contribute to TTHM. Because right now we are chasing TOC control, and all that, but I mean, what happened in the distribution system may be, how big of that is a factor, for TTHM violation. That would be good information to know. Okay.
Thank you. Well, it seems that we have at least another area that we'll be able to research and hopefully provide more information on in a later webinar series to address those questions, Martin. So before we switch gears, I just want to allow one more opportunity for anyone to come off mute and ask any questions or provide any comments or suggestions that they may have in regards to future studies or support that their facility may need, or any questions that they have in regards to minimizing DBPs or experience with DBPs within their distribution system.
More of a question to Aaron at PSD1 is he operating his dynamic mixers 24/7? I think it depends on each system, or how does he define how long he's going to operate those? I'm sure it has to do with flow and whatnot. We're seeing folks on, off, on 8 hours, off 8 hours, things like that.
I don't know if anybody is still there, because it seems as if they had to step away from the rest of the call to resolve an issue they were having. So Aaron or Charles, anyone that might be there? No, I think they have stepped away. So I will definitely be able, and it looks like he actually ended up providing his contact information in the chat. So it seems like you have the opportunity to reach out directly and see exactly, oh, wait. It looks like he's back.
I just heard my name there in the background.
Mike actually just had a question in regards to how often you are operating your dynamic mixers.
In the winter time, We usually are 12 on, 12 off. It kind of changes with the seasons. I know like summertime, we tend to leave them run a little longer just to make sure we have a better mix, but it kind of just depends with the season. I can add that with the information I send Trevor and them.
Perfect. Thank you for coming back so quickly. We appreciate it. All right. Well, if there are no further questions or comments, suggestions, anything about DBPs, we will go ahead and we will switch our gears a little bit into our more of an open format for just engagement. And we will actually be helping to lead this open engagement with Mike, who will be covering topics in regards to emerging concerns with lead and copper, as well as emergency communications. Mike, are you ready to start your discussion?
Sure. I don't have anything to present.
No problem.
But I'll give you an update, or the folks from West Virginia systems that we're trying to push forward or have a point of emphasis on lead and copper based on what's happening in Clarksburg. And I'm sitting here with Mark Wolf, an operator. So yeah, so if you have a whole town and you haven't hit the triggers, you may not have removed any lead service lines. What triggered in Clarksburg was some childhood, less than 5-year-old blood levels, where we have an assessment team that goes out and assesses the homes for exposure paths, and 3 homes we found where the drinking water was elevated, and started removing some lead service lines, which kind of shook some things up. This next summer, we'll be asking all the water systems to submit a materials inventory, which is just a way to prioritize what you have, what may be going on, and possibly taking some special purpose samples. Clarksburg is doing that right now. And we're doing some study on some older houses. Special purpose samples, yeah, about 1,200. So far in about 28 years, they've done 405 compliance samples, and in 2 or 3 months, they've done 1,200 special purpose samples. So the lab capacity or coordination of all that information is interesting. There's sequential samples where the rule, just check the first liter of water or the first draw, and they're finding that, yeah, it may be different liter by liter if you look at some of the data. Right now, we're looking at flushing for 5 minutes to come up with a lower value, but it's really interesting. On the map also is Benton Ferry, Michigan, I think is getting a lot of press. We're working with EPA and some corrosion engineers, Cornwell out of Virginia. But yeah, it's going to be a point of emphasis more based on what childhood blood levels were, and since we're the health department or state health department, we're kind of tied in with some of that stuff going on. They are doing a research project with Cleveland. Pittsburgh is out of it, taking maybe 30 special purpose samples from lead and non-lead lines. Battelle Labs out of Columbus is working on that. They'll probably be in here next week for their 3rd trip because the water is getting a little bit colder. But just to give you guys an update on what's going on here, the materials inventory form is in our Bureau Director's office and getting the blessings from the State Public Health Commissioner right now. So no other information on that. And well, we're stopping by Clarksburg once, twice, 3 times a week, just to make sure the flow of data is really you can get lost in it. And there are weekly calls with the regulatory folks for everybody involved. I'm not really associated with that much, but yeah, it's new and emerging. Seems like it's probably a good idea to update a rule every 30 years or so because there's new information. So that's topic number 1. Any questions, concerns? ideas on that.
We do have one question in the chat from Trevor and Bobby asking, what type of material inventory are you looking for?
So if you look at the Pittsburgh Water and Sewer website, they have dots at every service connection. They want to know what is on the service line for the utility side and what is on the service line, what kind of materials on the service line for the customer side. What Clarksburg had to do is go back and look in their index cards for original service, and that's where they came up with a number of those. And it looks like we haven't found any lead on the customer side. We're kind of scratching our head saying, well, why would you have lead on the customer side? I think if you're in a confined town where the meter may be in the basement or whatnot, that yeah, you could have some there. But it's mostly 40s and 50s construction type. These lead service lines are really substantial, heavy. Kind of wonder how they even placed it in there. So Clarksburg's material inventory is essentially about 20-some% complete because they found about 1,200 lines of 7,000 lines are out there that are lead service lines on the utility side. So they're formulating a plan to do that. We put everybody on increased frequency sampling. The 90th percentile value for Clarksburg was 13 parts per billion. The old trigger was 15 parts per billion, so it's under that. But you know, you get some high levels. You kind of wonder what's going on there. The new one will be 10 to 15. You'll be kicked into a trigger to remove the lead service lines at a faster frequency interval. So it's probably a good idea to get all the lead out. I think over the last 2 or 3 decades, it's kind of been found that there's no beneficial use for having lead in water. And the decimal point on the minimum detection limit has moved over the years.
Thank you, Mike. Are there any other questions in regards to the material inventory or the special purpose samples that Mike was referring to? All right, well, if we don't have any further questions, we'll go ahead and we'll jump into the second topic that Mike was hoping to discuss about emergency communications, right, Mike?
Correct. Most of the water systems in West Virginia should have received a letter from our director this week saying, in mid-January, we'd like you to certify that these mass alerts are going out to your customers who elect to sign into them. So if you go on a lot of utility websites, they're saying, well, click here if you want an update, give us a cell phone. I think legislature went through the last couple sessions to say that, the utilities should notify the customers that want to be signed in for this. And it's an attempt to communicate better, which is always good. Also, they have to contact the local health department and the county emergency services folks so that make sure we're all on the same page. So there's going to be a lot of information out there, and it's probably too much information to handle unless you happen to be that customer. And I could foresee in the future years that these locations are going to be more targeted, so that we're talking about blocks, not entire distribution systems of everybody. And it's going to take the customers and the utilities a little while to modify that and to make that understanding obvious. Bobby had a good question yesterday and saying that, we want to get this up and going, but it's in our next improvement project. I think the intent is that you get to know the emergency communicator folks in your county. I think they've got a good one in Marion County, in that if you're out of electricity and you're using your emergency generators, they'll come and fill them up for you so that you don't have to worry about fuel. So make sure you know those folks before you have that emergency. And I'm sending out some boil waters yesterday, and I'm kind of, I don't know who the contact is in Randolph County, because they're going through some changes there, or who the county sanitarian is. A lot of positions are unfilled in any utility or government entity, so you want to make sure that those are always updated. And it's better to have that relationship beforehand than afterwards. And it makes you wonder, you know, on a typical day, how many emails do you get? And if you're like me now, it's that's too many. If it's really important, they'll probably text me because I'm getting so many spam emails or from whatever previous method. So it's kind of where we're at now.
Great. Thank you, Mike. We appreciate the updates. Do we have any questions or comments in regard to the mass alerts that will be reaching customers? All right. Well, I want to open up the floor one last time to any general questions, comments, or maybe even suggestions for the study or support that you might want to see in future webinar series that could help you guys. Of course, this is about information sharing, but also, as Mike said, connection building as well. In the past 2 sessions alone, we've been able to kind of connect dots between different regions to help each other. So I'm really looking forward to the next session and seeing exactly what connections we can continue to build between all of our facilities throughout West Virginia and Pennsylvania.
Really quickly, I just wanted to go over that next session. We're going to continue our conversation on emerging concerns, more so focused on PFAS for the next session. We're going to have a presentation from Mitch McAdoo, who's on the call today, and Melissa O'Neill will also go through a little bit about different efforts that have been accomplished in the region to study PFAS. So we're really looking forward to that, and we'll also round it out with a discussion, open forum-based discussion, to really address any PFAS concerns, as well as finish up the discussion on anything that was discussed in the first 2 sessions. So we're really looking forward to that last session.
Perfect. Thank you, Rachel, for that preview.
No problem.
So with that being said, do we have any final concluding thoughts, comments, questions? All right. Well, I just want to thank you all for your participation in today's session. I hope you all gained something valuable from today. And please be on the lookout for the recording of the session that will be coming to your email and also available on the West Virginia Water Resource Institute webpage. Do not hesitate to reach out if you have any questions, comments, or suggestions relating to this webinar or anything you may be interested in learning about in the future. And I hope that you all have a great rest of your Tuesday. Thank you all for joining us again.
Thank you.
Oh, it looks like we have one final question. Are these sessions qualified for CEH hours?
I can answer that. We did put in the application for these to be considered CEH hours, and we're waiting to hear back and finalize everything. So we're working on it, and hopefully we can have an update at the last session.
Yeah, this is Brian Carr. We have a CEH meeting for the approval of these courses, and that is actually happening November 9th. So I foresee them being approved. So we will provide the CEH number as soon as it gets through the review committee. So that should happen late in the afternoon on November 9th.
Thanks, Brian.
I have a question.
Thank you, Brian. Yeah, go ahead, Aaron.
Is WVU going to be looking at moving forward, possibly hosting more and more classes as things progress? Or is this going to be as your guys' research process ends? And then if so, are you guys going to have a list for the next coming year of possible classes and stuff moving forward?
That's a great
question.
We are planning on hosting some webinar and seminar series related to other research that we have going on. That's kind of next in our docket. We do a lot outside of the drinking water world, but it might still be of interest. So we can share those webinars with the group. They're coming up this winter is when we're planning on scheduling them. And then after that, really it depends on what research we have going on and what opportunities that we see to really provide something of benefit for you all.
And I'll jump in. I think if it's something that you guys enjoy and find benefit from, I think, you know, if we were to set up something maybe like on a quarterly basis where we could just get together and talk about different things that are going on, we certainly can provide that organizational structure to have that happen. And if there's different topics that you guys want to discuss, I think that we could easily keep that going and find existing research that's happening around WVU or elsewhere that we could bring for presentation for you all.
I definitely think that'd be something that's a great resource, because right now with rural water and everybody else going on, it's so hard to find any classes or training, let alone something that's going in this in depth. So I think something that maybe WVU should consider sending out a survey of maybe some future projects or researches that different water companies would like to see, not necessarily pertaining to this specific subject.
Mm-hmm. Yeah, I think that's a great idea. I mean, we certainly don't want to step on the toes of rural water and what they provide. But if this is something that isn't currently being filled, then we can definitely step into that role.
Thank you.
Sure thing.
All right. Well, thank you, Erin, and thank you, Melissa. Thank you, Rachel, Lance, and Emily, of course, for presenting today. And thank you all for attending. Once again, I hope that you found value and gained something coming out of this session. And don't forget about our next session in 2 weeks on November 16th, starting at 9 a.m. I hope you all have a great rest of your Tuesday and stay dry if you're in the area. All right. Take care, everyone.
Thanks, everyone.